Yo, what's up, everybody? Welcome back. Today we are working on our async web server that we're using as the backend for this like meal tracker that we've kind of slowly been working on. The problem that we have been having is we have set up our whole system to be async, right? We have many connections that could come in from a web browser or multiple web browsers, and we need to make sure that when we respond to one, we are not like neglecting all the others, right? Since most of the time is spent in like I/O, we're not doing like very much actual work here. We need some sort of system to say like, hey, while this guy's like blocking me from sending him data, let me do like this other thing instead. So we work around this system called epoll. Maybe we do this. Epoll. So this is just like a mechanism on Linux to say like, I have lots of file descriptors, right? Please give me this number when they are listening, right? So, or when they are ready to talk, I guess. So what happens is in like the HTTP read case where we're like getting data, we try to read. They haven't like said everything that they need to say yet, and so we say, oh shit, nothing to do. Epoll, bro, could you let me know when there's more stuff? And also here's a pointer to some like something to like call when that happens. So he does that for us, and then we in the version 1 of this thing would just like do whatever we have to do and send the response. And that worked great up until it didn't, right? So as like our data grew and our code grew, eventually we get to the point where when we send something back, the other side is not ready to accept it all yet. Because like maybe like TCP buffer size is too small or something, right? Or like kernel buffers. So we say what happens is since our connection setup is non-blocking, that would error out and we would actually like completely fail to write. Bad. So we came up with a solution to this the other day. A couple days ago, we added this concept where our HTTP connection, he would, start by trying to read. He would like do some like HTTP parsing, whatever. And then eventually he calls out to our like application specific context that says like, hey, could you like, send the response to like whatever this request was. And we then would return this like new pollable structure, which is very similar to what we were giving to epoll, except that it doesn't do like file descriptor registration and stuff like that. We just assume that like the parent connection already has the correct stuff set up. And then we can just say like, hey, parent, like HTTP connection, when epoll says that they're like ready to accept stuff, can you tell us to send the stuff that we want to send? And that worked like okay, but it kind of falls over when you consider this case. So let's say someone comes in and they're like, read big ass file, right? Read a big ass file. This in the current form would go into HTTP connection, who would call context serve. That's us, right? We return a like pollable thing, like make progress, essentially, right? Make progress. Now, imagine that in this like make progress thing that we're doing, we might want to first send like the HTTP header. So this is like from memory. This is like from like memory, right? We've just kind of like constructed this response in a buffer in RAM somewhere. But then say we want to send like big file as the body, right? Big file out here trying to stop us from talking about, so I don't know, man. I don't know. Here we might want to use like a different call, like Sendfile or something. I haven't really thought this all the way through, but in here, this guy actually has two cases where he could run out of data, right? One is that like disk slow, and the other one is network slow, right? And with our current mechanism where we're kind of relying on HTTP connection to like keep track of when we want to talk to our guy, what happens is if we can't do this right now because disk is slow, but net's ready, this will just never complete. Right? Because we'll be like, oops, I guess we gotta stop for a second, and then we'll be waiting, like, hey, let us know when like the network's ready. And the network's been ready the whole time. He's always been ready. And so what we really need to do here is we need to like register with the event loop a second time for this like file descriptor for reading from disk and stuff, right? So that's the problem that needs to be solved. In happy hour yesterday, we tried like a couple solutions to this. We tried like registering new stuff with the event loop directly, and we also tried I don't remember. We tried something else. But the result was like never really quite there. What I want to do today is set up some sort of like chain of actions. Support like just like in our event loop, our epoll wrapper. Support any chain of handlers, right? So like we could be like read file A, then send to TCP connection B, and then like, you know, read response, and then like write file C, right? Right, like this sequence of actions should be like relatively easy to work with, and right now it's not. And what I'm thinking is that the event loop, we have like two things we can say to it right now. We can say, hey, we are like not done our thing, and like we're done our thing. Those are the two things we can say. And I think that all I want to do is add a third thing that's like, you know, swap to new action. Right? This is kind of all I want. And this way it allows us to just have like a state machine that walks through like 5 states or whatever and can interact with whatever file descriptors he wants in any of those states. And I think that that'll kind of work pretty well. I think. So that's what I want to work on today. So, replace, I think we'll call it replace handler. Where handler, you know, you might want to look at epoll edge trigger for this. At least for the read-write dependencies. I thought epoll, like, man epoll. Man 3 epoll, maybe? Man 2 epoll, man... epoll CTL, maybe? Where... God damn it. Where is the definitions for this stuff? We have somewhere make epoll event who has, you know, edge trigger set here. Where are these defined? This would be, these are used in epoll CTL. Oh, here we go. I thought that just said like edge triggered. Request edge trigger notification for the associated file descriptor. Not really sure how this is that related here. Not sure. Not sure what you mean. But anyways. Let's do this. So this guy, he can replace what file descriptor he's associated with and what function is going to be called when that file is ready. But it means you can return it to the poll set after it's gone through high, and it won't trigger again until you get into the again. But you don't need to trap the again to learn about it. Oh, interesting. I think I understand. I think. With edge triggered, what doesn't it mean that you have to make sure that you only submit it when it's high and then it goes low? Like, I thought that is what edge trigger was, that you need to trap the E again to learn about it one time, or like before registering, but maybe I don't understand what you mean. Talking is hard. Okay, but I don't think it's really. I think that like the concept is still okay here. I think. Um. So he gets some handler. Let's just put unreachable here so that we start compiling. Let's kind of figure that out first. And it looks like that's kind of it. Okay, cool. So we need to, I guess, is it easier? I think it's easier to start somewhere where this will happen, and then we can kind of work our way backwards from there. So HTTP connection. He now needs to, when he calls into our guy, I think he can just return what he gives us. So our context will return a poll result now. And we just return that thing. I think. Which means that like our specific data will be freed. So all data associated with our connection will go away, which means that we shouldn't be passing that arena or our allocator into this guy anymore. And then I think we're kind of chilling here. Oh, I see what you're saying. You're saying that you have, if the read side high level, write side low, you can put both read and write in poll set. Read won't be returned, never went low, but write will once it's ready. If it was the other way around, write high, read low, then you get a result when read goes high, what you want for the dependent mode. I think I understand. I see what you're saying. But I think that you still need both if you don't know which one caused the problem. I think. But I think I understand where you're going now. And I think that whatever I'm planning on doing will still work. I'm okay with just like registering the same handler for both the read and write end, and then being like, just fucking, I don't know, try whichever one comes first. You know what I mean? Like, fuck it. Okay. So, yeah, that works too. Okay, cool. I'm not like completely out to lunch. Okay, so our serve function now needs to return a poll result. That is his new job. Or, no, sorry, poll result. And so he can choose whether or not he just wants to nuke the connection, if he wants to, you know, get called again, or if he wants to replace the handler. I guess. Maybe it's kind of wrong for him to ever return in progress, because I don't think that he will ever get called again by the HTTP connection. But fuck it, I guess. Okay, most of this stuff is going to be wrong. The vast majority of this is going to be wrong until we figure out the new interface. And so let's do like a little unimplemented here. He doesn't want a connection allocator anymore. He's going to handle that shit himself. And that means this kind of goes like this. So he's going to return a poll result, probably. Or maybe he just returns a new handler. That's probably more correct for this API. This handler needs to be associated. We need some like memory to be associated with this thing. So do we have like, we might have already added response alloc root there. Yeah, we do. So we have like an allocator that we can attach to this thing. We can say, you know, maybe this guy takes in self here as a, what the fuck is this thing? HTTP context. It's like self response allocator. We split off a sub allocator where all of this responses stuff goes. We can like nuke later. So this is like JSON response here. And so all of this stuff goes here for now. Bang, bang, boom. And we need to, like, maybe let's start with just returning a handler. Actually, we can kind of do, respond buffers is probably very close to what we want. FD refs buff writer. Yeah, so we can just also make this thing conform to the handler interface, since they're very similar. So this is like, I guess we just nuke the pollable vtable. This thing's gonna go away. So we turn this into the handler vtable. And I guess it's like this. Bang, bang, boom. Okay. I think he also needs a file script here. Okay. Okay. Now this returns a handler and oopsies, not this guy. This guy. He returns a handler and he returns ret handler instead. Okay. Simple. Then it's like replace handler or something. What do we call it? Is that right? Yeah, it is. Okay. I think this guy is erroring out when he shouldn't. And then, is everyone else happy? No, what's he mad about? Because this guy takes in a parameter now. This takes in the event loop, like for cases where we wanted to like spawn new connections and attach them to the event loop or something. That's like supported in here. I think this is just gone now. Okay, so he's happy. And we can start trying to use this thing, and presumably what's going to happen here is we're going to try to interface with this guy, and he's going to crash because he's going to say that we returned that, like, replace handler, and that's not implemented yet. Yeah, sick. Replace handler, unreachable. That's exactly what we wanted. Okay, so what happens when this happens? I guess all we have to do here is, okay, so before we would like maybe do nothing, we would maybe try to remove this thing from the epoll list and like, you know, because we're done with it. I guess in this scenario, all we have to do is maybe we just say this handler is equal to the new handler. Because the thing that we're giving to epoll is an index into some array. Yeah. And that array, if we just replace the element in the array, then we're kind of chilling. Now, this won't work if the file descriptors are different. Right? If they're different, we have to actually, I guess we go like, if new handler FD is not equal to handler FD, then we probably do like a register of the new handler kind of on its own and remove the old handler. And we probably, we can't do this now though, because epoll only supports. No, it's fine. I think that's fine. So we register the new handler. We assume that there's nothing in epoll associated with that file descriptor right now. And then we remove the existing file descriptor. No. The handler index. Then otherwise, I'm using edge triggered, not level triggered. Otherwise, if they're the same, then we're allowed to just swap it out. But you bring up a good point that, like, maybe we need to be level triggered. Because like right now, we should pull the new handler to ensure it's not ready right this second, right? So we might have, like, this is gonna come up later. But we'll figure that out. Are you passing file descriptors into a thread? Everything's happening on single thread right now. We haven't really done any, like, multi-threading for this yet. What's he miss about here? Oh, this thing can fail? That's fine. I think that's fine. Error union is ignored here as well. Okay. And what's this thing pissed about now? Void. Whoa, what the fuck? Oh, there's a dot there, I see. Okay, there we go. So, I suspect that what's going to happen here is it's going to hang because we're not doing the first pull that we need to do on this guy when he's ready to go. Yeah, so here we're hanging because we have to pull one time before we put it in the loop, or we need to make this shit level triggered. Yo, did you end up succeeding in running the barcode scanner? I've only watched the first 2 videos so far. We're not done yet. I know sometimes I say we're not done, we're going back. This one we're like very, very, very actually going back. This is should be a very slight detour. Because I have like 6 other things that I want to do that like are related to the barcode scanner. And so it would be a real shame to like cut that whole branch off. So it's just that this web service stuff is blocking me from using my meal tracker on my phone right now. And so I want to get that fixed. But then right back on barcode scanner. Okay. So I guess it just means someone needs to be in charge of polling. This is kind of like a bug right now in general, right? Where things need to be polled one time unconditionally. And arguably they should be polled in this section, right? If we like register a bunch of stuff and then call the event loop later, everybody should do like their first action if they can. And so I guess that means that like we probably want like a force poll list. Probably. Maybe we say like typical size, max size, and then we'll put this here, and then we can just use the same parameters for both. Okay, cool. Okay. Good afternoon. Good afternoon. So, I think every time we register something now, we just like put it in the force poll list. And then here on wait, we go for each thing that we want to force poll. Maybe even before epoll wait. Yeah, it's like kind of like the first thing we do here is like go over each thing. And we look at like handler pool at index. Yep. And it's like we almost want to do this same thing down here. which means that like maybe this gets split out somewhere. Um, maybe like this? I don't know. I don't know, man. Boom, boom. And here, in reality, we should like call poll handler on the new handler probably. Like unconditionally. Yeah, something like this. And we have like, you know, later we need to put the removals somewhere. So removals is probably one of these. I actually don't know. To remove is runtime bounded array. Yeah, sure. Um, this is wrong because maybe what we do here is we put this in like force pull append index again. Uh-huh. Wait, that seems pretty good. Okay. Because register will like register also force pulls. Okay. Then we don't actually do the polling here. That'll happen on the next iteration of the loop. Does modifying this loop while we're iterating, does modifying this thing while we're iterating fuck everything up? It might. It might. Yes, I mean, I'm not like 100% certain because as long as we're only adding to it, this is not like an array list. This is like our own type that I believe the iterator is kind of like every element has like a stable memory location, and the iterator is working off indexes into this thing. So as long as we're only adding, I think it's fine actually. I think. Does it realloc? No. It like it's a data structure that looks kind of like we have like an initial block, and then as we run out of space, we like add new blocks. But like the existing blocks never move. These guys like stay in the same spot forever. And then like maybe if we like delete this whole block, we'll like nuke it. But like these guys are like stable pointers. These guys never change. So by appending, we're only like adding new blocks. And the iterator might hold state about how many blocks there are. Current slice index end. No. Unless block iter, parent, block index, start end. Ooh, start and end is interesting. Oh, but start and end are like flags. Like these are like we're trying to iterate some range. So this will end up polling things at the end though, which is not good. Like this iterator will iterate into the things that we added, even though it's not like memory invalid, it might be like logically invalid. Okay, so that means that we can't. This guy. We need like two add here. This like I think it makes things easier. And this is gonna take in handlers probably. force like will be pulled on addition. I think that makes our lives easier. Okay. So the number of things that we could remove in this iteration is now like the number of events that could come back from epoll plus the number of things that we're force pulling. And so we should be like a const max update size is number of events plus force pull. Okay. Okay, to add is handlers here. And then here we can call like self pull handler at index with to remove and to add. Okay. Cool. And then we do the same thing down here. Okay. I think that this will hurt my brain less if this is not a self function anymore, because it doesn't actually need to do that much stuff on here anymore. So can we, if this guy takes in the handler instead, I think there's nothing else self in here. Oh, no, this isn't here. Yeah, okay. Fine, we'll leave it that way. It is a little confusing though, but that's okay. Scratch checkpoint needs to be updated at the top now. And this stuff should move into a function. Function, pull forced. And I guess we have the same parameters that come in here. I guess. Okay. And then at the end of this, once we're done this, we can nuke this whole structure because we've pulled all of these, so we're chilling. You know? So here we like clear. Does this guy, what's he do? Free unused blocks. Yeah, I guess that's fine. I guess that's fine. Okay. What's this bad about? Handler index. Area needs ignored. Okay, sure. True. This guy needs to be tried. True. These guys are not double pointers, so we can remove those ampersands. Okay. And this guy's mad because we didn't pass to remove and to add here. Okay. Easy peasy, lemon squeezy. And then we have handled our removals. And we just need to handle our additions now. And which I think is just like register handler. And then we loop again, and we do the rest of them later. So if we end up doing... Ooh. So we don't want to get stuck on waiting here, though, if there's stuff to do. Right, we only want to do like an epoll wait if there's nothing left. So here we want to say like, if to remove items len equals 0 and to remove items add. or to add items len is equal to 0, that is the only time where we wait. Right? Yeah, and this thing is a usize. Okay, so now in like the majority of cases, like in the case where we have forced work to do, then we'll have num fds is 0, which means that we won't call any of these handlers, but we will still work through the removals and additions, and then we'll loop again. So maybe. Wait, holy shit, a Zig user. Wait, holy shit, a Nix user. Hell yeah, dude. So this should fix the problem. Oh, hello. Another segmented list bug. Nice. So it looks like if we try to call clear on an empty list, this just fucking breaks. That's kind of sick. Slight little detour here. So he's mad here. Unused blocker. We fixed this, no? I swear we fucking fixed this before. Was it this? Whoa, 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 whoa. I swear we fucking fixed this somewhere. Did we not push it? Fix crash on shrinking empty runtime segmented list. Yeah, this is here. And we are working off this. Oh, sure. So we just rebase. Okay. Git rebase origin master. Love it when it just you're adding to remove while iterating. I know. That's fine. We're not iterating to remove when we're iterating to remove. I'm pretty sure. Pretty sure. I could be wrong. Okay. So this seems to be working. We are definitely like adding things and we're getting responses and nobody is like freaking the fuck out. So we should be good there. Should be good there. Okay. So now I guess we can try doing some more complex stitching. So we should have everything we need in order to do like a Sendfile. Oh, wait, maybe not. Because we don't support registering with multiple file descriptors right now. Okay. So I assume, first of all, I've never like used this before, but I assume that this will fall over. I assume that this won't like buffer forever, right? I assume that we need to schedule this shit. If we're trying to copy from a file descriptor on disk to a file descriptor over network, I assume that it will only copy the amount that's available right now. So let's try to make something that can do that. Yesterday we started on this connection state machine. I don't think that this doesn't really match what we want anymore. So I'm fine with just kind of nuking this and rewriting it because also happy hour viewers didn't get to see it, or non-happy hour viewers. If you don't mind me asking why Zig over CPP, I'm a CPP user, so curious. It's funny to come in here and be like, holy shit, a Zig user? And then be like, wait, but why would anybody use Zig? It's like, why are you so excited about it then? I've made a video about this in the past, so I don't really want to rehash the whole thing. But I don't really think C++ is, I don't like it, is really the answer here. Why I don't like C++. Dude, the internet did not like me on this one. But I will link this if you want to watch it. But also, if you don't, the short of it is I just think that like C++ is a shitty language. I think it's like way too hard to use correctly. Way too hard. It's just cumbersome as fuck. Yeah. And yeah, there's just like so many foot guns. The templating system is a pain in the ass. The like classes are I think I'm like over destructors, to be honest. I think I'm like not into RAI anymore. And like just writing a class to do something simple is so hard. So hard. Right? If you're just like, I want like bounded array in C++, you have to write like four constructors, 5 constructors. You have to like make sure that like you're not accidentally copying memory when you should be moving it and all. It's just hard, man. Okay. I like RAI, but more like the Rust form. Yeah, the Rust form is better. Specifically because in Rust you move by default and you don't have to deal with copies. That really helps. But I'm kind of on the side now of sometimes you don't want to free each vector. Sometimes you want to free all the vectors at once, right? Like theoretically, not that it matters, right? But like theoretically, like if you have like some nested, like some like nasty tree of vex, right? These all have like one lifetime. And so like the idea of having to like walk this tree and free every single vector when you could just like nuke the whole pool is like a little silly. It probably doesn't actually matter, but I do like the idea of like not having to run destructors if you don't want to. You know what I mean? Okay. What are we doing? We were trying to write a thing that goes from write header to Sendfile. That's what we wanted to do. So we can uncomment maybe file system reads here. And here we need to figure out how to do that, right? So we want like, instead of reading all this shit, we want to open the file with fspath1 to target end, because we're stripping the leading slash in the URL. With I don't give a fuck flags, probably. And here, then we make an HTTP header with some response alloc. Whoa, hold on. Wait. Before we get to this, we're not done here. We're leaking memory, I'm pretty sure, in the current form, because this guy creates this response allocator and never frees him. That's a problem. That's a problem. So this respond buffers guy, we need to chain like a free onto this thing. Yeah. So we need to say, once you're done sending these buffers, I want to call free here. Which means that it's time to introduce the connection state machine. So probably here, we probably want like a write buffers is this, right? And then we want like something that does write buffers, and then I think that the way that we found worked for this the other day is if we had like a on finish thing. Yeah, this looks familiar. Yeah. So we actually had something. We had something for this the other day in happy hour that we can kind of reuse here. So we can just say like, hey, when you're done, could you call this finish response with response alloc is this guy and the connection is the connection. So he's gonna say like, when I'm fucking done, close the connection, free all my memory. Okay. I think then it's like return, like, state machine is this. We probably attach this to the response allocator. And then we probably call, like, return state machine handler. Probably something like this. We just have to, like, make this thing. Okay. So, the previous incarnation of this was not right, but he had some good ideas. So this is going to return a connection state machine. Now, does this thing actually have to be a generic type? Yes, because we have the, like, completion context. So this guy needs to take the type of the completion context. And he has, like, an allocator. And he has some handlers. Okay. So, what is this guy going to do? This guy takes in a completion context, returns a type. And what has he got in here? Handler index. He's got handlers. So he's gonna, like, iterate over these guys. Cool. Is that it? Completion context. The things that we do when we're done. This guy, I think, can implement the handler interface. I think. So he has pull and close. Okay. Boom. Oopsies. God damn it. Delete, 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 close. Okay. So I guess on close here, we're probably iterating over all of our inner handlers. Probably. I don't know, man. Probably. We could maybe close them as we go, but maybe just doing them all at the end is fine as well. We definitely call completion context. And we probably go with, like, for self handlers. It's like handler close or something. Probably something like this. Okay. And then on poll, it's like if handler index is greater than or equal to the handler length, return complete. We're donezo. I bet you that this is done in a loop. I don't really have a good reason for that. It just kind of feels like the type of thing that will be that way, because I feel like we're going to be iterating multiple handlers here, but we'll see. For each of these handlers, or for this handler, we go like, oops, we poll him. Okay, and if he says that he is in progress, we return in progress. There's nothing to do here. Pretty sure. If he wants to replace his handler, I don't really want to handle nesting of these guys right now, so I'm just gonna hit an unreachable here. And if he's complete, this is where it gets interesting. So if he's complete, we probably return replace handler in most cases, right? It's probably like, hold on. So we increment the handler index. If The handler index is greater than or equal to self handlers len. We return complete, which means that this should never fucking happen unless the handlers list is empty up front, but that should also never fucking happen. So I think it's okay to just like assert this. And then if this is ever not true, we can like tell someone to go fuck themselves. And that someone would be us, because we're the only users of this. Okay. Otherwise, I want to say that we continue here. No. Return, replace handler. And we need to like construct a new handler for ourselves, right? So it's like, we need this thing to like work off the file descriptors of our child, but call us, right? So it's like pointer is equal to self, vtable is equal to our vtable, but the file descriptor is self handlers at self handler index.fd, I think. We link it to their file descriptor. Is epoll significantly easier to implement the server compared to IU ring? I've just never looked at IU ring before. My guess is yes, but it's on the list of things I want to look at some point. This is getting a little complicated. But maybe that's just like the world of async. Why you gotta go and make things so complicated? Why? Okay. That's like a maybe. Why is this airing out? I don't know, man. That feels like it might work. Okay, so that means that this while true was wrong. Our U-ring gets fun when we want to get the kernel to own the buffers, which is a big efficiency buff. Easier in Zig though? Hell yeah. That does sound fun. It's on the list of things that I want to look at one day. It's been on there for like years. Okay, so when we make this thing, what do? We duplicate the handler list so that we don't accidentally do something fucking stupid. We probably return this thing as a pointer. Probably. I think that's just like, I don't think we'll ever not want it as a pointer, to be honest. So we probably create a connection state machine type of completion context. Okay. And we'll team Manda here. We're gonna bracket. We probably do like ret. It's getting a better time to do it now than ever before. We'll continue to get better. It was pretty buggy early on, not gonna lie. Sick. Maybe I'll take the jump one day. Not for this project though. Maybe. Maybe we'll do it when Zig 015 drops. Because they're going to implement, like, they're gonna like drop this whole new writer interface, and it would be fun to try to implement our own writer backend with IOU ring. So maybe that's the time to do it. We're gonna duplicate the handler list here because I know for certain I'm going to pass stack allocated list in here. It's just I can't fucking stop myself. I can't stop myself, and so we fix it by just duplicating memory to make our lives easier. Handler index is gonna be 0 up front. And completion context is completion context. Easy. And I guess here we should assert that handlers len is greater than 0. Or, yeah, it's fine. Okay, and then this guy needs to like have a thing to register with. He needs a thing to register with the epoll thing. So sure. And in reality, this guy can probably just return a handler. That kind of makes our life easier. Because then we can just have this as like an implementation detail. So it's like pointer is ret vtable is can we just do like this? Like this. Boom, boom. And then pointer or FD is handlers 0 FD. Easy. Yep. Okay, so now we try to use this guy, and he's like, we can just return this guy like this. This goes away, and he's mad at like this. Okay, so we respond with the header, then the response body. We'll see what happens. This thing, he expected a handler. True, dude. I forgot. So what is this guy? This is a handler. So maybe like this. What's he pissed about? Try here. Expected something found out of memory, because I forgot to write try. What's he pissed about? Expected this found that ampersand. And ampersand here. Little pointer, you know. All that jazz. I like how if I say all that jazz, there's like a quick flash in my brain that says don't say all that jizz. And it's like, come on, man, we don't have to like brain, stop it. Stop it. Like we don't that was never a risk. It wasn't gonna happen. So like we don't have to like guard against it happening because we weren't like there was no world where we say that. Like, shut the fuck off, brain. Okay. So now we have a thing that can stitch together multiple things. This should prevent memory leaks. We can confirm that we would have been leaking if I comment this out in its current form and I kind of just call this a few times. And we should be able to see, like, if I go to... Oh, we can't look at the memory results though because we don't have the ability to send those results yet. Okay, so we'll come back to this. We'll come back to this, but we do have like a memory tracker that we can use, but it's exposed over HTTP, which we don't have fully implemented yet, so it's okay. We can actually implement that now, and then he'll come back. Memory usage. Let's uncomment this guy next. Stud event. Okay, so I think that this respond buffers guy is actually should be the one in charge of hooking up this, like, on finish. I think that makes more sense here. Response alloc here goes like this. Then we can just return this like this. And then this stuff just goes in here. Buff writer, boom, boom, buff writer, and then this is like response alloc here as a pointer to asphalic. Boom. Okay. I think that's pretty good. Yeah. Okay, so now we need a response alloc here. Memory usage like this. Boom, boom, boom. This guy needs to allocate from his arena. This guy needs to allocate from his arena. Ooh. Hold on. Is that true? Yeah, the response buffer comes with the arena, the header comes with the arena. Intermediate work comes with scratch, and then we return here with response alloc. Okay, he's mad because we probably have to write handler here. Yep, get the types right. And whoa, what is he pissed about? I probably have to write try here. Okay, and then what's he pissed about? Expected some shit, found handler. True. Do we think that this should just return a poll result? So that I don't have to fucking type this everywhere? I feel like it should. So then we get like a handler is this, return, replace handler with handler. Boom. Cool, and then that's gonna break this as well. So this is return with a poll result. Okay, hype. And then this is just like this now. Bang, bang, boom. Okay, so we should be able to like use that memory tracker now. Local host, no, memory usage. Memory, is it just memory? Yeah, it is. Okay, so here, that's bad, right? We can see as we spam refresh, memory usage is going up over time, so we're doing something fucking stupid. And what's interesting here is you can see the HTTP connection buffer going up, but not the allocator that we're using for memory usage, right? So this is actually, we can look for HTTP connection in here, and it's this allocator is never getting freed. Probably. So that kind of indicates that this close function is never called on this guy. Probably because when we do our replacement in the event loop, we have to call close. Right? So when we have this replace handler, to remove is supposed to do that. He calls close here. So maybe we're not removing him? You know what I mean? That's like a possibility. Definitely a possibility. Because this should be happening. Let's just see. Hi, Mom, I'm on TV. Is this not happening? Like, it should be happening. Yeah, see, we're seeing that we're definitely seeing that we do hit this path sometimes. Does that mean that we're not closing the connection? It's okay. Bye-bye. Bye-bye. We gotta fix this build speed as well. Yeah, so that bye-bye is never happening. So that's kind of confusing. That must mean that this guy... Ah. So because this guy is returning replace handler? Oh no, that should be fine. Something's wrong here. Oh, it's this path. So we're in the path. I see. So in the case where the file descriptor is different, we do like our remove and add. But in the cases where the handlers are the same, we don't actually have to do this like add or remove shit, but we do have to call close on the old handler. It's here. Right? Because we're replacing the old one, which means there's no like index shuffling to be done. But we do need to like clean up old resources. Aha! Look at that shit. So stable, baby. Refresh. And then we should also confirm that if I start adding things, this is still the same, which is good. And we can confirm now that if we... like, if we were to, in respond buffers, not respond with this like state machine that cleans up memory, but instead responded with buff writer directly. This is kind of the state that we were in a minute ago. This would also leak. And that would be bad. Pretty sure. Yeah, see? You can see it cranking the fuck up. Does that make sense? Okay. Hype. Hype, hype, hype. Okay. Cool. So now, this is a lie. Now we should be in a state where we can try to implement Sendfile. So, because now we have this like state machine that we can walk through different handlers in. So we should be able to, in like the file system one, if they ask for something off disk, now we should be able to, you know, open file with, you know, open on this shit with I don't give a fuck options. We should still be able to make the HTTP header out of this guy. And he goes on like response allocator. I kind of feel like maybe the response allocator should just be here. You know what I mean? Like, is there any world where we don't want this thing? Yeah, probably, right? So we make the response allocator here. And then, like, we could even do, like, alloc name for parse target or something, right? So that we can, like, figure out if we're fucking something up in, like, one path, at least we would, like, get that. And even here, we can do, like, tag name like this, right? That's good enough, to be honest. And probably if we error out here, we probably want to free this guy. To be honest. Yeah, probably. Probably. Okay. So that means this guy goes away. And this gets this guy here. And then this respond JSON turns into this. Nice. And then that means that, like, memory usage here, we don't have to make this guy here. He just already exists. Hype. And then we don't have to make him here either. He already exists. Okay. Content length. So we need, what? It's like file get end pause. Content len is this. Boom, like this. Okay. Now we respond buffers with response alloc, but we're not responding buffers, right? That's the whole point. Is we want to chain together a buff writer that works off of literally just the header here. Does this guy copy? Yeah, he does. Nice. Nice. And then this becomes like, do this, then a Sendfile. Yeah. And our Sendfile is something that comes from event Sendfile or something, right? Sure. And we initialize him with like the file handle and the connection handle. Seems reasonable. Maybe we'll find out that this doesn't work later, but let's get there. We'll get there when we get there. Okay, so he's implementing handler. And I guess we implement pull and close, whatever. It's like this. On close, I think we're doing nothing because these are references. Yeah, we're gonna have to think about this a little bit, just kind of like in general. The fact that our close is like not always expected to actually close stuff is kind of fucking weird now. That's something that has to be addressed. But for now, we'll do this. So maybe like refs makes this more obvious that these file descriptors need to be handled by someone else, right? I think that's fair. Okay. So what's happening here? We have source. We have dest. And we have init. I guess if we're going to use DS2, we should use SRC. Otherwise, we are not consistent. And we love consistent around here. Okay. So this guy's going to do like a Sendfile, right? I guess here we need to make sure. Okay, so we were talking before about how file descriptor, like, which file descriptor we wake up from epoll could change. But we can kind of just fix this by saying source is blocking, dest is dest is non-blocking. Then we don't have to think about it. For now. For now, which is still an improvement over before. Send file blocking to non-blocking. Send file blocking to non-blocking references. It's the perfect name. What more could you want out of a name, really? Neither is owned. Okay. Fuck, that's funny. I mean, really, maybe what we should do is we should have like a, you know, like FD ref or something. You know what I mean? Is like, you know, we could have something that has like owned, or I guess it would be like come up more like struct here. You know, handle and owned, or something like this, and that would make it really obvious for if we should be like nuking this shit on close or whatever. But a problem for future me for sure. For sure. Okay, send file blocking to non-blocking refs. And this is just like, I guess there's nothing to do here. It's like source is source and dest is dest because we're assuming that they're already set up correctly. This guy is like, yo, hit me with handler. Or no, this is send this shit. Pointer is self, vtable is vtable, and then we just have to implement pull, which is like, you know, we say, give me my self pointer back. God, thank God for autocomplete. Or else I'll be losing my fucking mind. And I guess it's like stood, posix, Sendfile, no? Out, in offset. So we need an offset here. Okay. What is it? It's out, in? Out, in offset. In len? Whoa. Does in len have to be set? I guess so. Whoa, man to Sendfile. Um, can I not write 0 here? I guess not, huh? it doesn't say that I can like there's no like sentinel value here for just fucking do the whole thing. So I guess we fucking shove that in here. You know the one thing I miss from other languages that Zig doesn't have is like const fields. I feel like are kind of fucking nice. The idea that like you have a thing and you're like I won't fucking change this. That's like such valuable information to my brain when I'm trying to like parse through like mega state. I guess it's fine, but wait, this whole time I could have been having headers and trailers. I could have been doing this from the start. We didn't need this whole system. Shut up. Fuck. That's my bad. That's funny. This actually supported what we wanted the whole time. That's funny. What is... There are no flags here in the man page. So I guess fuck it. Oh, wait, hold on a second. This is like... Is this a Zig extension? Whoa, what's going on here? What is like the syscall that this is going into? Yeah, okay. This is a Zig extension. So that's why I didn't know it was there. That makes sense. Cuz I feel like I would have noticed. What are flags for then? Is that also a Zig extension? This is for system send file in offset out offset bytes flags. Okay, wait, hold on. Oh wait, that's for FreeBSD. So this is just not used in the Linux version. I see. And then I assume that this returns total written. Nice. So we say like self offs plus equals this. And I guess it's like if error is equal to error would block return in progress return E. And I assume that this guy will return would block if it's E again. Nice. So this should do what I want. Should. What do we call this shit? Sendfile blocking non-blocking refs. Okay. So, hype. Okay, he doesn't like this. Wait, why? Unable to evaluate. Oh. Sure. Switch on the parsed target. Inline. Then we go like inline else. We have tag name. There. So this like creates a switch statement of all the possible options. It's like this, right? This makes a switch of all the possible options, then generates a tag name for each of these guys at compile time, which means we can go like alloc name here. Two-step used to say all the time, convert to a comp time value. I'm like, what the fuck does that mean? You can't convert to a comp time value. But I guess that is kind of what this is doing. You're like making a switch that you can parse things at comp time. Unable to resolve comp time value. Oh, so that's funny because the sub allocator thing needs a comp time value here. That's annoying, which means that we actually have to make this guy like response alloc root make sub alloc with tag name t. That's funny. That's funny. Okay. Oh, this is not self anymore? True. So the API in Linux is Sendfile, but it's a copy. I like said I was expecting web thing. Well, I guess like, you're sending to a TCP socket, right? Like copying to a socket is the same as sending to the internet, right? But yeah, it is a funny name. All right, we chilling? Handler doesn't exist. Why not? Because this thing's cons probably. I guess this. Yeah, fine. Oh, this is a problem. This needs to live on the response allocator, or else this will reference a thing on the stack. Which means that this guy, like in reality, this should just return a pointer. Well, and like I guess like there's more flexibility if he doesn't, but less chance of me fucking it up, and I will fuck it up. I will. You can't stop me. It's just better to do like this. Bow, bow, bow. Okay. If I recall correctly, Sendfile started as a free BSD thing. I have no idea. Hello? Oh. There you go. What's this guy pissed about? True, we do need to say which file we want to be associated with here. This guy, I guess this is true that we can't return errors here, which means that we return complete and log an error. Failed to send file with this reason. Return in progress, I guess? Whoa. Yeah. Or is this like a while true type shit? I think this is a while true. Just keep fucking going until you exit out for some fucking reason. And then maybe it's like if self offs is equal to self len, return complete or something here as well. It's like the typical exit condition. Probably something like that. All right, what do we think the chances are that this fucking works? I'm at like a solid 40%. Okay, looks like that's a no. What the fuck is happening here? Curl localhost, no. Index HTML. Oh, okay. Interesting. Lots of interesting things here. I should be using splice. My bad. My bad. Do you guys think that that's a bug? Do you think there might be some like memory corruption here? Or do you think that I have this many handlers? What's happening here? This is coming from handler poll on poll forced. Okay. It could be that the index here on poll forced. Oh, we're not healing poll forced on removal. That's a bug where we after a swap remove, indexes are wrong, so we need to go over Oh, but I guess forced should be empty here at this point, right? Because on poll forced, we nuke the list here. So it should be empty here. Let's just slap one of these here really quick to make sure that's not the problem. Because I don't think it is, actually. Anymore. Okay. Yeah, that's not it. Okay, so while we're going through forced items, let's take a little peeksies at, 10. P index. 2. Okay. So index is larger. That seems like a problem. Hello? Oh no, sorry. This is force pole. The first element is 2, sorry, and then that goes into handler pool. Okay, so this is len 11 and or sorry, len 3. But index 2 is still fine in here. So we have blocks pointer 0 3 in here. Okay. That's interesting. Or sorry, index 2. Okay, so this does seem like a reasonable thing, right? We have a connection state machine in here. Okay. So that kind of indicates that this thing is this guy sane? No. I assume that this here is A's. Yeah. So this is invalid memory in the handler's pointer in the connection state machine. Interesting. And this is on file system. So this guy is bugging. How? Am I accidentally freeing this thing all the time? Error defer only? So how the fuck is his memory invalid? Oh, also, fix me close file. We're leaking file tubes here, but that's for later. Huh. Oopsies. Yeah, I don't really understand why this would be wrong. Thinking. I guess it could be on, like, transition somehow. Okay. Can we... hold on. Leaky. Notify is the thing that happens on finish. We do nothing. And then we can pass leaky in here. And then that should... Whoa, what's happening here? Unable to resolve comp time value? Why? Struct requires comp time because of this field. Types are not available at runtime. Okay, what's the fucking problem? Hello? It's from this thing? Why? Completion context. Oh, here I need to say, can I not use type of on a type? I thought I could. I thought I could do this, where I could do like type of leaky is just type, right? I don't like RAII 40 minutes later. We're leaking file descriptors here. Shut up. Yeah, so this is a type. So why can't this work? Call to generic function instantiate with comp time only return type error out of memory is evaluated at comp time. Wait, what the fuck is the problem here? Am I fucking stupid? Because I swear I've done this before. I guess handler? Handler is technically a runtime type or something? No, he's mad about this. Alec create. Can I just do this? Does that fix it? No? Am I fucking mental? Dude, I'm lost. Unable to resolve comp time value. Call to generic function instantiated with comp time only return type. Out of memory is evaluated comp time. Oh, maybe it's because I'm allocating? Because this is a generic function instantiated with comp time only return type is evaluated. Struct requires comp time. Types are not available at runtime. Yeah, interesting. Interesting. You can't allocate comp time, but I'm not trying to allocate comp time. I'm trying to allocate with this thing like this, right? That's what I'm trying to make. I'm trying to say, make me a connection state machine where the context here is of type. Oh, I see. So like type doesn't have like a size. I see. So we can't allocate a thing like that. Oh, that's interesting. Okay. So this doesn't work, which is fine. We can just do like this, right? Right, we can just go like this. Kind of solves the problem. I just thought you could do it with type only there. There we go. That does the same shit. Okay, so what was I trying to check here? Curl this thing. What were we doing? Oh, okay, right. Okay, so if we don't free, this works. So that's good. So that means like the Sendfile part is working. Now the question is why the fuck are we freeing before he's ready? Whatever. Right, so I assume here, can we just do like std debug print imom? Oh, I'm a dumbass. I'm a dumbass. This close is getting called. This close. uh, this gets called on every single iteration of handlers. So we're freeing on the first iteration. On the second iteration, we're like, what the fuck? So we need to go for like, if handler index. I think we do like, we flag like is finished. And then here it's like is finished is equal to true. And then here we say like if not is finished. I guess like technically this only happens if handler index is silent. We don't need this. Right? We do this. If self handler index is greater than equal to self handler is len. Or this is less than. Return. And we'll just say this is called for every iteration. We only free at the end. There we go. Easy fix. Easy fix. Just don't be stupid. Okay. Nice. Curl. Refresh. So this is bad because we're leaking again, but we didn't actually bring back the proper thing. So on finish, this is like we have the connection, we have our alloc, we have a sphallic, and then we have our file, which is a std.fs file. And then we say self file close. We have alloc dinit and close connection, probably in this order. Whatever. Do I get paid for this? I make like less than minimum wage from ad revenue and subs, which is like something for sure. Like, I can't complain. But no, I'm like, I am on what is turning out to be a very extended break uh from working because this is just a lot more fun. Okay, good news. Curl, 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 curl. Refresh. Nothing's fucking broken. So no memory increase. It is a little concerning that we have 8K here all the time, but I think that this is the cost of this call in particular. So the fact that it's not moving is good. Yeah. We'll be clear, it's not because I can't get a job, it's because I don't want to. Said everyone who didn't do anything because they couldn't. But like, I haven't tried for a couple of years. So we'll see. We'll see. Maybe at some point. I'm kind of under the impression, as of right now, that if I just do this for the whole time that I'm not working, it's not like there's like a big gap in my resume, so people shouldn't like just completely write me off. Although at some point I'll have not worked with another human for so long that people will think that I'm incapable of communicating, which is true, but I don't want them to know that, right? So we'll see. But for now, we're just enjoying coding for fun because coding is fucking fun, man. We love it. Okay. I think that this interface is a success. That's my read on this. So the idea that our event loop now supports replacing handlers with other handlers means that we can chain any sequence of actions of like arbitrary complexity. It would be nice if we supported like flagging, like working off multiple file descriptors as like our notifiers, but that's fine. That's like a future problem. And yeah, I think that's a win. So I think we'll call the end of the YouTube segment. I think I'll probably keep going on some cleanup here for happy hour. But yeah, for those of you who are watching the VOD, thanks for watching. If you like what you saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. Some portion of that ends up on YouTube, some portion does not. Basically, it's like we try to keep it, under 2 hours, and with things that are like titleable and thumbnailable, right? Because, you got to keep the algorithm clickable, So the rest of the stuff we put on Patreon or as Twitch VODs or under YouTube members. The reason that we do that is because we want to give people who want to support the stream something back. The stream, as we were just saying, will end when I run out of money, right? So if you want to continue, make sure that the stream stays alive. Please consider supporting, because that is kind of the metric. When I run out of money, it stops. But obviously no pressure. I think that's it for now. YouTube, peace out, and Twitch, let's keep going.